Alright, let's look at the homework 9.4, problem number 8. Alright, biologists stocked a lake with 1,000 fish and estimated that the carrying capacity to be 6,000. The number of fish tripled in the first year. Alright, let's look up part A. Alright, assuming that the size of the fish population satisfied the logistic equation, find an expression for the size of the population after t hours. Alright, so it's a logistic equation, so we actually know the form of the solution. Alright, so we have P0, so you start out with 1,000 fish, and the carrying capacity is 6,000, so that's just a given. Alright, so this means that the M, so 6,000 minus 1,000, which is 5,000, and divide by 1,000, so it's going to be 5. Alright, so we put 5 here. Alright, let's submit for testing. Alright, so looks like we got these guys correctly, so let's look at the second part. Alright, we have P of t equals 6,000 over 1 plus 5 e to the negative kt. Since population tripled in the first year, so P of 1 is, I guess, 1 year, is 3,000 because it tripled from 1,000. Alright, then let's see, we set that equal to each other, so let's see, I'll put 1 here, and this is equal to 3,000, and we multiply both sides by, I guess we should write that down now, hold on a sec. Alright, so we are setting a P of 1, so P of 1 is equal to, alright, so you have 6,000 over 1 plus 5 times e to the negative k, then t is 1, so that's it. And this is supposed to be equal to 3,000. Right? And I guess first thing I would do is I'm going to actually go ahead and divide through by 6,000. Right? So that will make the 6,000 to 1. Then you have a 1 plus 5 e to the negative k is equal to 3,000 divided by 6,000 would be 1/2. Alright? Then we can get the desired expression by taking the reciprocal of both sides. We get the 1 plus 5 e to the negative k is equal to actually just 2. Alright, so answer here is 2. And then we can solve for e to the k. Alright, so first thing I would do is we can just subtract 1 from both sides. We have 5 e to the negative k, and that's going to be equal to 2 minus 1 is 1. And then I'm going to divide through by 5 to get e to the negative k is equal to 1 over 5. Then we can just take the reciprocal of both sides. Then you have e to the k is equal to 5. Alright, so this is 5. So answer is 2 and 5. So let's put that in. And 2 and 5. Alright, submit for testing. Alright, looks like we got these guys correctly. And therefore, k is equal to, so we can take the natural log of both sides. So it would be natural log of 5. Alright, thus P of t. So we just need to put this guy in there. So let's see, how do we do that? We have 6,000, so that's on numerator, and 1 plus 5 times, alright, so e to the negative k would be 1 over 5. So we can just put 1 over 5 there. And then we can raise, so this is 1 over 5 is e to the negative k. And you have to raise it to the t power. So you just raise it to the t power. Alright, so let's submit. Alright, it came back and looks like we got this guy correctly as well. And let's go into part B there. Alright, looks like they set up the equation for us, and we're setting that, let's see, how long will it take for the population to increase to 5,000, right? So we have P of t set it equal to 5,000, and of course multiplying, and we can get e to the negative 1.6094 t. Alright, so let's do that computation. Alright, so first thing I would do is just divide through by 6,000. Alright, so that will give us 5 over 6, and I knock out the 3 zeros, and is equal to 1 over 1 plus 5 e to the negative 1.6094 t, right? Then I'm going to just take the reciprocal of both sides. Then we get the 6 over 5 is equal to 1 plus 5 e to the negative 1.6094 t. And then I'm going to subtract 1 to get rid of this 1. 6 over 5 minus 1. 1's 5 over 5, so it's going to be 1 over 5 is equal to 5 times e to the negative 1.6094 t. Alright, then we just have to divide through by 5. So it's going to be 1 over 25 is equal to e to the negative 1.6094 t. Alright, so answer is 1 over 25 there. Alright, so let's type it in first. Alright, so this is going to be 1 over 25. Alright, let's submit. Alright, I came back and looks like we got this one correctly. Alright, then last step is just solve this equation for t. Alright, so I'm going to use GeoGebra here. Alright, and the first thing I would do is we take the natural log of both sides. So you have a natural log of 1 over 25, right? That will get rid of e, right? We still have to get rid of negative 1.6094. So I'm going to divide through by negative 1.6094. That will isolate the t value. So I'm gonna hit enter. All right, and let's see, 2 decimal places. So I have to see a little bit more. And so I'm gonna hit option and rounding. And let's see, 2 decimal places. I'll try to see more. All right, so actually I had it right. So it's a 7 point. Actually, this is exactly 2. All right, so I guess you have a 2.00. All right, so let's submit. All right, it came back and looks like we got this one correctly as well. All right, that's it. I hope that this was clear.